All right. Hello, hello. Testing. Everyone can hear and see, I guess. Um, okay, I'm gonna turn off the video and do the screen sharing. Um, I guess this one. Oops. And I will keep everything open. If everyone can give a thumbs up, if you can hear me, you can write it in the comment section. All right, great. Okay, so let's get started. I have few slides. For some reason, I can actually hear my echo. Not sure how I can do that. Anyway, so welcome to building amazing. I'm actually not here. I don't want to do this. There we go. Trying to see if I can. All right. So welcome to building amazing apps using ARKit for iOS. A little bit of my introduction. My name is Mohammed Azam, and I am the iOS as well as the web instructor at Iron Yard. I also have a lot of courses on Udemy, Lynda, and you can follow me on Twitter at Azam Sharp. And also you can visit my website, which is azamsharp.com. Let me actually fix my mic for some reason. Hello. Can you hear me still? Oh, okay, good. So that's perfect now because I cannot hear myself. So that was very annoying. All right. Okay, so let's begin. WWDC 2017, Apple introduced the ARKit framework. Now, the ARKit framework is the augmented reality framework, and it is based on the Mataio framework. So in 2014 timeline, Apple bought a company, I think it's a German company, Mataio, which is a really good company which made the augmented reality framework. And it was bought by Apple in 2014 timeline. Audio, video not working, is that correct? Can anyone else confirm? Okay, so Kenny, okay, so there might be something wrong on your side, Kenny. Use the Chrome browser. That's the first thing. If you're using Safari, might be a problem with that. So augmented reality basically allows you to create or place virtual objects. Like you can see on the left-hand side, there's a missile, and on the right-hand side, there is a toy car. And so it allows you to place virtual objects in the real world, so the world that we live in. So you can use the ARKit framework to create these kind of things. The more realistic your design is, or the more realistic the models that you're using, it will be very hard to distinguish between the real object versus the augmented object or the virtual object. Now, both of these screenshots that you see, they are obviously virtual objects. There is no missile in my backyard, and there is no toy car like that in my backyard. So these are all virtual objects. But if you have models that you can download or pay for and use that are like real objects, then it's very hard to distinguish. All right. So that's pretty much it. Let's just get down to the actual demo and see how we can actually start building augmented reality applications. All right. So first of all, you will be needing Xcode 9. All right. And you can download Xcode 9 from the Mac App Store. Let me know what size is okay. I think this size should be good enough. Okay. So if you go to File, New, and Project, so I'm using Xcode 9, and if you use File, New, Project, you're going to see that there's a new template, augmented reality apps. All right. And you can use this template to start building an augmented reality application. So this is going to give you at least some sort of a starting point to build an augmented reality app. Now, I have already done that. I have already created an augmented reality application using the template. And if you create using the augmented reality template, and if you simply run it, then let's see what happens. So I'm going to just run it. And now you need to see or look at my phone. So here's my phone. Let me see if I can actually go into airplane mode. So everyone can see my phone right now, right? The one with the flowers in the background. Okay, so this, now you have to have a phone, like a physical device to run this. iPhone 6S or above should be good to run this. Now you can see now you might be feeling over there that it's very sluggish, but that is because we are sharing the video or screen sharing online. It's actually very, very smooth when I do it. Okay, so I'm going to do it a little bit slow. So this is by default you're going to get when you create an augmented reality application using Xcode 9 without typing, without writing any single line of code. All right, so this is what you're going to get. You can see a spaceship, and if I try to go closer to it, you can see that it sticks right where it is, and I can look at the spaceship from many different angles. All right, and I can even go under the spaceship a little bit. Here we go, and I can look under it. Okay, so this is what happens when you create an augmented reality application and using ARKit template and run it without writing any single line of code. So let's see what's going on in the app. Now I have written a little bit of code, but that's for different purpose. So if you go to the storyboard, which is where you design everything, let's see if it opens up. The whole system is now running extremely slow because it's sharing at the same time. Not sure why my camera is on. I don't think you guys can see me because I thought I'd turn it off. Yeah, usually it doesn't take that much time. Okay, so on the storyboard, you can see there's only one view, and that view is the ARSCN view, which is called the Augmented Reality Scene Kit view. So when you're building augmented reality app, let me actually do that for you. Project, augmented reality app. And if you're building augmented reality app, you have choice of what technology that you want to use. So you can use Scene Kit, you can use Sprite Kit, or you can use Metal. So Sprite Kit is a 2D game development framework. You can use it to build your augmented reality app, but it wouldn't really make that much sense to use Sprite Kit because it's a 2D framework, two-dimensional games. So think of games like Mario Brothers, or think of games like Asteroid or Galaga and all those things, or Pac-Man. So using a 2D framework to build something like augmented reality, you can do it, but then everything will be kind of like 2D. you won't be able to go behind the object. Metal is a framework where you can use to build, would say, games like Counter-Strike. Those kind of games you can build. And SceneKit is a framework by Apple which you can use to create games like Zelda, games like Crossy Road, and all those fun kind of 3D-ish kind of game, but not like ultimate 3D game like Counter-Strike and all of those. So I'm using SceneKit, and this whole demo will be using SceneKit. All right. So this is the augmented reality view, which allows you to show the camera. And in the art assets folder, you can see the ship.scn file. This is the actual model of the spaceship. And if you create an augmented reality app, you will, using the ARKit framework, you are going to get this for free, obviously, from Apple. So let's see how we can do a little bit different stuff. So I don't really want to display this spaceship. So I'm going to simply remove this part because I don't want to display the spaceship. All right. What I want to really display is just a red cube, just a cube, a box, a square. So let's go ahead and build something like that. I'm going to create a box, and it's going to use the SCN box class. Now, SCN box is not the actual box you're creating, it's the geometry of the box that you're creating. All right. Now, what is geometry? Geometry is kind of like the wireframe that you're creating. Okay. 0.2, 0.2, 0.2, and 0. Now, you might be wondering, why am I giving 0.2 over here? I mean, 0.2 is very, very small. I mean, you won't even be able to see this. But 0.2 over here in augmented reality or in ARKit, it is 0.2 meters. All right. So everything in augmented reality is in terms of meters. So 0.2 meters is actually pretty big. All right. Okay. Now we will create some sort of a node. So if you want to display anything using the SceneKit framework, which we're using SceneKit, then you have to convert that thing into a node, or you need to create a node and add it. So that's why I'm going to create a node, and I'm going to pass in the box geometry, which I created, which represents a box. This is a box geometry, which represents a box with this width, height, and length. Okay. Where do you want to put it? So if I don't give any position to put my node, it is going to be where exactly I am sitting and holding the phone. And I might not be able to see it because I might be in the place where I'm actually sitting. So I want to give some other direction, the position. And since we're in a 3D world, we will use the SCN vector 3 and pass in the X and Y and Z. Now, Z is the most important thing over here, because Z will tell you how much further you want to put it away from you, or you want to put it at 0, or you want to put it on a opposite side of you. And everything is in meters. So I'm going to say, put it away from me, 0.5 meters. Oops. Right? So we are putting the node, which represents a box. It's a 3D box. It's a 3D cube, 0.5 meters away from you. Away, because that's negative. All right, so let's finally add it to the scene. Root node.add child node, and then add the node. Go ahead and build it. Everything might be a little bit slow because there's so much going on the screen right now. So, sure it's running over here or not. Okay, so it builds successful, but let's go ahead and actually run it and see if it shows up on the screen. Yeah, everything is running a little bit slow. All right, here we go. Now the X, Y, and Z position is going to be determined by the way that I'm holding the phone when the app is actually launching. So here we go. You can see the cube being displayed. And I know that on the video, it shows really, really sluggish, but it's not. It's actually very smooth. It's just the video transmission. It's very sluggish. Okay. Everyone can see the white cube being displayed. And it is a 3D cube. I can go over it a little bit. Don't worry about the backdrop, which is blue. That's for my Udemy videos backdrop. That's now permanent over there. Okay, so this is great. But I want to change the color of this to red. We haven't really. Yes, you can actually make each side a different color if you want to. But what I'm going to do is I'm going to create a material. Material class is going to allow you to create a material that you can attach to your wireframe. All right. Now that material can be a color. That material can be an image. So it can be anything. All right. So we are going to use the material class for building it or for making some sort of a color. Wow, Xcode is pretty much taking a long time to build, like at least 10 times more. And even for these simple builds, it's taking so much time. All right, so what I'm going to do is I'm going to assign material and some sort of a color to the material, which is one of the properties of the material, which is diffuse content, which represents that how the material is going to behave under different light. Okay. Now, finally, I need to assign this material, and you can see the box class or the box object has a materials property, and I can simply pass this material that I just created into an array. Now, a box has 6 sides, so if you have different materials, you can simply just add a comma and start adding more materials so that your box will be different color on each side. But I only have one material over here, which is red, so I'm just going to use that one. Once you have the material, I think that's pretty much it. Let's go ahead and run it. So now if I run it, I should see this being displayed as a red box instead of a white box, which is a default color. If you don't apply any color, it will be white. All right, so we're just waiting for this to launch. There we go. So you can see now that the color is now changed to red. All right, by allowing or giving some sort of a material. Let me do one thing. I'm going to go into a little bit less resolution and see if that will help. Okay, let's see if that will actually help us or not. All right. Okay, so that material is great, but I want to apply some sort of an image to it. Now, I already have some sort of an image over here, which is brick texture.jpg, and I want to apply this on all the sides of the cube. So let's go ahead and do that. Instead of UI color, I can simply say UI image and pass in the name, which in this case is brick texture.jpg. All right. And I think we might have to unwrap it or something, but let's go ahead and run it and see that now if each of the sides of the cube are using the brick texture or not. It's still building, taking a bit of a time to build. And here we go. You can see that now we are using, instead of the color red, now we're using image. And if I try to look at it from a different angle, you go over here, you can see that all the sides of the cube are now using that particular image. And it looks a little bit real. Like, I mean, obviously, if you are trying to fit in your virtual objects in the real world, then you have to decorate them also with some sort of a real world content, like a brick texture or something, right? And the same way you can use something else, like same way you can create sphere. So we already created the box. You can actually create a sphere using SCN. It pops up. Here we go. And you can give it some sort of a radius. I'm going to say 0.5. You can create some sort of a sphere material. SCN material. And then we can have the similar thing for the sphere, where we are going to use some sort of an image. So let's go ahead and use an image for the sphere. I already have the image. I'm going to use something called earth.jpg. Okay. And finally, you need to apply sphere.material and apply the S material that we just created for the sphere. And now we can actually create a node. And pass in the geometry, which in this case will be sphere. And then some sort of a position. So I'm just going to copy this position, which we had earlier on, and apply to S node.position. And finally, I will apply or add S node to this. So it's pretty similar to what we did earlier. The only difference was that we are now adding the sphere instead of the node or the box that we created. Okay, so let's go ahead and, oops, I think it's going to take some time to, let's go ahead and first save it. All right, so let's go ahead and run it and see what it displays. Now, the earth.jpg represents the texture of the planet Earth. So if it displays correctly, you should be seeing a sphere, and on the sphere, wrapped around the sphere is the image or the texture of the Earth. And obviously, you can see it's running a little bit slow because of a lot of stuff going on, but it usually is pretty fast. Like when you're running, it's pretty instantly runs. If you're connected using a wire, which I am. So it will be much slower if you're using a wireless debugging. Okay, so we don't see the sphere because I think I might not have applied the material. Oh, here it is. See? So make sure that you always put the position into something a little bit away from you. And the sphere is way too big. The Earth is way too big, as you can see. So I have to a little bit move back for you to see. I'm just going to move back a little bit more. There we go. Everybody can see the Earth. Now that looks really good. And there we go. You can see the planet Earth. And you can go different. I can go from the top and I can go on the other side of the planet Earth. Absolutely. So if you give negative position, so where's the position we are giving? Over here, right? So instead of 0.5, let's give it minus 1.5. So that is, once again, this is 1.5 meters, not pixels or points or things like that. It's always is going to be meters. So what I have done is I have increased from 0.5 minus 0.5 meters to minus 1.5 meters. Let's go ahead and try to run it again. It's going to take a little bit of time, but hopefully it will pick it up. Here we go. And here we go. It's a little bit further away from me. And now you can see the whole planet Earth. Most probably you will need to give it like minus 2.5 meters or something, because still it's a little bit too close, I would say. All right. But you get the idea. So take the position that is that works for you. Okay. All right, so these are just creating different objects or shapes, decorating them with a material. But what about if you want something else? Like if you want to, can you create an irregular shape? Yes, you can create, or you can combine different objects together to create those irregular shapes. So let me actually show you some of the things that you can actually use. Here we go. Okay. Hold on a second. It's too slow. All right. So this is Google or Google Blocks. All right. It's not really for augmented reality. It is basically for creating virtual reality content. And one thing you can do is you can use the Google Blocks library, or gallery, and you can add, or you can use any of these things in your app. So let me actually show you what. All right. So you can download these things like, let's say this well, or this red roses or flowers. And you can import these models into your application. All right. So here we go. Some nice flowers. You can, on your computer, you can go to this and you can see it. But if you download this, this will be in the form of a wavefront OBJ file. All right. Now you can use it. You can use an OBJ file. You can load an OBJ file into your iPhone application or an augmented reality application. But what I tend to do is I try to convert the OBJ file into a Collada DAE file. And this is one of the examples. So this is OBJ file, which I loaded it over here. And all you need to do, and this, by the way, this program is called Blender. It is for free. You can download it. So once I import the wavefront file, which I have downloaded from Google Blocks or somewhere else, I can export immediately to Collada format. The reason that I do that is that I will be playing with one file and not two files. Yes, you can also change the material. And that's actually the reason that I export it to Collada, that I don't have to mess around with the material and the folder structure. Whenever it export to Collada, it kind of export it as a single file, which already has the material and texture and everything, so that you can simply import it and start using it. Now, I already have converted it into a DAE format. And here is a fish that I have. This is already in the DAE format. So how do I load this? How do I load this fish into my application? So let's go ahead and look at that. Loading a DAE model. All right. So the first thing we're going to do is we are going to create a brand new scene using fish.dae. All right, so let's go ahead and do that. So I'm going to say fish scene, and scene over here represents basically, a scene represents a scene. Just like in the movie set, a scene can have a lot of actors and a lot of different objects. That's the same concept over here with the scene. The name of the scene over here is fish.dae. Okay, that's the one that I'm going to load. But I'm not really interested in fish scene. What I'm really interested in is the fish inside the scene. And if you look over here, the fish inside the scene is indicated by something called fish model. And you can change the fish model if you want to. I can go ahead and write any name over here. Make sure that you select the fish, and then you change the name of the fish or the identity of the fish. Okay? So this is a fish, and you can have this is a scene, and you can have multiple objects in the scene or multiple models in the scene. So right now I have fish. I can have a tree over here. I can have a whale over here, or a shark over here, and then another fish over here, or a goldfish over here. And I can simply load the fishes using their identifier, which in this case is fish model. Obviously, all of them will have different identifier. All right, so let's go ahead and get the fish node. So once we get the scene, I can simply say fish scene dot root node dot child node with the name. And what is the name? It's called fish model. Recursively, yes. So this is how we will get the fish node. And that is what I really wanted. Once I have the fish node, I can simply add the fish node just like the way before we were doing it. So scene.root node dot add child node, and then add the fish node. One thing you will keep in mind is you haven't really defined any position. And by default, the position will be 0, 0, 0, x0, y0, and z0. Most probably you want to change that because x0, y0, z0 will be the position where I am actually physically sitting, and I won't be able to see that. So once again, I'm going to give it, put the fish, but a little bit away from me. Size, by default, if you load, if you're loading a DAE, so the size really depends. You can change the size, by the way, but let's go to the fish.dae and check out the size. So if you click over here and make sure that the fish model is selected. So this is the bounding box. So this is the actual size of the fish. And you can see its scale factor is right now 111, meaning it's scale to the original size that it has. You can change it by giving over here. You can say 0.5, 0.5, 0.5, and that will scale it down. Or if you want to do it in code, you can simply change it fishnode.scale, and then you will be able to change the size of the fish. All right, let's go ahead and give it a 3 over here, I think. I think that should be it. Let's go ahead and run. Okay, let's see. Okay. Still building, I guess. Once it is building, it will run on the phone, and we should be able to see the fish if everything is correct. So here we go. It's loading. There we go. And whoa, it's way too big. Even with minus 0.8, you can see the fish is too big, right? And one thing you will also notice is the fish looks very pale. I mean, it doesn't have any design. It looks really pale without any color. And that's because you don't have lighting enabled on the fish. All right. Now you can add a default lighting by simply one line of code. You can simply say scene view dot, let's see what option comes up over here. I think there are two options, but I just need one of them. Enables default lighting equals to true. So that's going to enable default lighting. This is not a perfect solution for everything, obviously, because some things can be dark, some things can be in different, different lighting conditions can produce different results. So, but it's going to be good enough for us in this example. All right. Once again, Xcode is painfully slow right now. Okay. And obviously the Xcode is not as slow. It's only slow because I am sharing the screen and I'm doing a lot of different things. I'm also running a QuickTime and all that stuff. So just bear with me, sorry. Okay, so now I'm gonna run it and hopefully it will show us the fish, and you will notice, look at that. Did you notice that now there is, you can see how sharp the fish looks now? That's because we have enabled default lighting. You can see the texture. And that's a very good question. So what's going on right now? The fish is definitely being displayed. I mean, I can see the fish, but that's not really the way I would like to see the fish. I mean, it's kind of, I'm looking at the fish from the top, and it looks, I mean, it's okay, but I want to kind of like rotate the fish and I want to adjust so that it appears nice, right? So I'm going to tell you a trick of how you can do that. But before that, let's take a small break. And I would like to tell you a little bit about the Udemy course that I have. And everything is covered in this Udemy course. Loading of the models, scaling them, loading. And I mean, it covers like a lot of different stuff. So I'm just going to paste this URL over there. The great thing about these links that I have put over here in the Medium article, and I've pasted it in the Crowdcast webinar chatting, is when you click on it, it will go to the page of the Udemy course, and it will already apply the coupon. All right, so it will already apply the coupon and get the price down to simply $10. All right, but one thing to keep in mind is that this is only available till tomorrow. I think this deal is going to run out till tomorrow. And the great thing, another great thing is that it is applying this for all the other courses as well. So if you want to learn Core ML, you click on this link and $10, and it has around like close to, what is it, 1,200 students registered. The ARKit course has around 2,300 or 2,400 students registered. So it's 7 hours of content that you can consume, which contain loading models and so many different things like building a remote control and integrating with ARKit as well as the Core ML. All right. So I've pasted it on the Medium article on the chat if you're interested. And all of these courses have a deal going on, and I hope you like it. All right, so let's get back to it. So the question is, we can see the fish model, but the fish model is not really displaying the way we want it to. And I'm going to tell you a trick that will save you a lot of headaches. All right, are you ready for this? And it took me a while to figure this out, but once I figured it out, it really helped. So right now, if you select the fish, this is what you're seeing right now. But when you load it, you are looking at kind of like this, right? I want to look at the fish kind of like this. So if you select the model, And see over here at the bottom, it says perspective. Change that to front. That's just the camera. It's not going to like automatically change everything, but it's going to tell you that if you are looking through the camera, through the augmented reality, your iPhone camera, this is what you are going to see. All right. And it's actually correct because this is exactly what we saw when we ran it, right? Now you can adjust it over here in the Euler angles. Instead of 90, we can simply give it like 0. And that's kind of, that's kind of what I wanted to do. I want to also maybe rotate something over here, and you can test these out. So okay, that's not really what I wanted to do. So I can actually, test it out. Okay, do I want to do that? Maybe I want to do 180. Okay, that looks pretty good. But the trick over here is that you change this from perspective to front so that you have a better idea of how it will look like when you're actually running the augmented reality view. And that's the trick. And that's going to save you a ton of time because this front camera view is the same view which you are going to see when you run the app. So let's go ahead and run the app again and see our cute fish. All right, might take time to build, but once it's built, let's see. There we go. All right, there we go. Wow, now that is beautiful, right? I mean, that is really, really nice. And obviously on your side, you can see that it's a little bit sluggish, but in reality, it looks actually really nice. And with the automatic lighting support that we have enabled, we can actually see really, it really brings it to life. You can see the crisp and the sharpness of the fish. I can look at it. I'm sitting down, so I can't really go that close to it. And I don't with fish like this, I don't even want to go close to this one. But you can see. Let me see if I can go a little bit near it. Might be a little weird, but let's see. So I have to stand up and actually. There we go. You can see the fish. Now I am constrained because I am connected to a wire. But you can see. You can go and look at the fish. All right. All right. So that is, remember, whenever you're trying to rotate something, always switch the camera from perspective to the front and then start messing around with the Euler angles or the degrees and all that stuff. Okay. All right. So loading and everything, that's great. What else we can do? So one of the things that is really great about augmented reality is the plane detection. Okay, now plane detection means that augmented reality view is going to find out where the planes are, and it is going like a flat surface is. So why is it so important? Well, it's important because once you find a flat surface, you can put stuff on it. That's the whole point, right? Now, if you had to do all of these things like finding a flat surface, it's extremely complicated. There's a lot of math involved in that. But the augmented reality team from Apple has made sure that this is as easy as baking a pie. So on line number 96, you can see all we need to do is to say configuration plane detection horizontal, meaning it can detect horizontal planes, meaning it can detect a carpet, it can detect a table, it can detect anything horizontally. It cannot detect anything that is vertical, so it cannot detect walls. So it cannot detect if you are looking at something vertical, all right? Not only that, but the plane detection, it has a little bit more criteria that you have to have good light, and you have to have a texture-based surface. So if you are trying to detect a very smooth surface like a wall or like a really smooth and polished surface with no texture, it is not going to detect that because it's not going to find any points or feature points that are called to detect the flat surface. All right. So let's see how we can do that. Let's see where it is. I think I have to, let me see, I will just enable the debugging so you can see what's going on. So I'm just going to go over here. So it's always a good idea to enable debugging when you're doing plane detection. Here we go. This is nothing. I mean, this is simply enabling the debugging. So you're going to see some points being displayed on the screen. And some of the code that I've written, and this is a little bit of a code that will generate or detect plane. Now, I don't want to go that much into the code. You cannot detect walls because walls is a vertical plane. And right now, the ARKit can only detect horizontal surfaces. So it can detect carpets, anything flat. So think about anything flat, but anything vertical, it cannot detect at this point. Maybe in the future it can, but right now it cannot. All right, so let me go ahead and run this. So right now what's going to happen is that it's going to detect planes, flat surfaces, and whenever it detects a plane, it's going to put an image on the surface. Not only that, but it's going to find out that if that plane is part of a much larger plane. Now, that is not done automatically. I have written some code that actually performs that. But whenever it finds that that plane is a part of a much larger plane, it's going to combine those things. So let's go ahead and see that. Here we go. So you can see that blue grid. So that's the image. So whenever it detects a plane, and look at that, what's going on. Whenever it detects another plane, it then combines it with the original plane because it knows that it's part of it's the same surface that we are talking about. And now you can see that I have detected a plane, and now it's actually getting. There we go. That's pretty large plane that we have actually detected. All right. Now, the great thing about this plane is that we can actually put something on the plane. That's the reason that you will detect a plane. So if you are building an IKEA app, you are going to detect a plane, and then most probably you're going to put some furniture on it. You most probably don't want your furniture to be just, hanging around in space, right? So that's how you're going to put the furniture on. I'm just going to copy a little bit of a code, and we'll go over it, that what exactly is that code doing. So the tap function over here that you see is going to get invoked whenever I tap on the screen. It's going to get the scene. It's going to get the position where I have tapped. And then it's going to find out that if my tab, the position, the XY coordinates, intersected with any plane. If it did intersected with any plane, then I'm going to add a TV, a flat screen TV on that particular plane. Where is that flat screen TV? Well, that flat screen TV, we got it from the Google Blocks. And let me actually see if I can show it to you over here. So that is the flat screen TV I'm talking about. It is created by Paul Michael. And this is what it looks like. That's just one model. I mean, you can use any model that you like, obviously. Okay. So let's go ahead and can one image detect plane and another not? TV on wall and blue grid on ground? I don't think I understand the question. It's detecting the plane because we are actually whenever we're adding the plane, it's basically this code over here. Where it is? Yeah, we are adding the plane to our collection, and then whenever it detects a plane, what's going on is it's sending a array, or it's sending a hit test, and if that hit test is not empty and it's hitting a plane, then we have a hit test against a plane. Now, this hit test can also be done if you want to see that if you have touched not a plane but a virtual object like a node, like a fish, which is not a plane. So yes, you can. It's a different kind of a hit test that you do, but you can detect that. So let's see if it actually if we can actually set up the plane. And let's see if I have all the code necessary for that. So the first thing I need to do is to detect the plane. And it's going to fire in. Here we go. So it's detecting the plane, and if I touch the screen somewhere, it's going to put a TV. There we go. Now the TV is resting on the plane, so it's not going to go anywhere. And I can go close to the, once again, I'm a little bit limited, but I can see, I can go close to this TV. I can go on the back side. Obviously, I can't really go on the back side, but you can see that I have now a TV in my home office. It's a, or a display. It's a virtual object. All right. So that's it. That's how you will detect a plane, and that's how you will put the objects on the plane. So you can think of apps like furniture and IKEA apps, or measuring apps where you can measure from one point to the other point. That will use detecting the plane, and you can create unlimited amount of apps. If you can detect the plane, if you can detect a flat surface, then you can create a whole virtual world and put it on the ground on the flat surface, right? I think that's pretty much all the examples I have right now. I mean, I do have a lot of examples, and I highly encourage you to download it from the Mastering ARKit for iOS Udemy course. One thing I forgot to mention is that if you use the course, if you download the course, if you buy the course, you will also get a free copy of ARKit for iOS Developers book, which is a very detailed book, covers everything from what we have discussed and way much more, like touch detection, collision detection, and all of the other stuff. You can follow me on Twitter at @AzamSharp, and don't forget to visit my website, which is azamsharp.com. And if you have any other questions, I'd be more than happy to answer. But apart from that, thank you so much for coming. I really like to do this, on more often basis, not only on augmented reality, obviously, but different topics. Sometimes augmented reality, sometimes Swift, sometimes MVVM or lean controllers, and a lot of different stuff I want to do. So once again, yes, so collision detection is handled by Contact Delegate, and if you have, let me actually see where it is. I'm just trying to see where it is. Yeah, in the Mastering ARKit course, collision detection, here we go. So we have a collision detection target shooting game that you build. Let me see if I have my iPhone over here. Let's see if I can actually run one of the examples. I will have to find. All right, so these are all the examples plus some more that you will be able to create using the course. So I don't know, where is it? Where do you see collision detection, target shooting game? Okay. So here is a little bit of the target shooting game. that I show how to build in the course. And oh, that was close. So you can see that I can shoot and it whenever it hits the target, it turns into green. So I can shoot it over here. And obviously, all of these targets you can replace with your own objects, like spaceships or something else. All right. So I've already shared this. I've also sent you an email with all the links and the GitHub and all of these things that we saw today. All the demos are available on GitHub, and I'll send you an email with the link, with also the link to this. So if you haven't bought this course, buy the Mastering ARKit for iOS, or go to the Medium and any course that you like. Server-side Swift, Paper 2. Server-side Swift is getting a lot of attention. So definitely check that out also with Core ML, with machine learning, ARKit, a lot of stuff with great things to learn. Okay. Any other questions I can answer? Once again, thank you so much for coming. And I will be sending an email out to you with everything that we discussed and a link to the book, link to the course, as well as a GitHub repository. And I hope to see you maybe in the future. I will definitely, I'm working on a few chapters on the book, and definitely will be writing. And once it is complete, you will be getting an email. Let's see, I think I might have a, okay. All right, so if you don't have any other questions, then that's pretty much it, and hope to see you in the future webinars. Thank you so much.